I was asked in a live stream on how to make a blunt start thread. That was a bit much for me to handle on the live stream, so I promised to make a video, and this is me keeping my promise. Let's do blunt start threads now. So what are a few ways that we can get a blunt start that looks something like this? Let's open it up and see our options. Here I can create a sketch on the XY plane. I'll make a circle. Now, for this particular use case, I'm going to suggest that it's optional if you wish to dimension that circle or not. Normally, it is not a best practice at all to leave things undimensioned, but here when I make an extrude, and then I go into an external thread, you can see that as I select a circular edge, and I create an actual modeled series, right? So if I say Acme stub, for instance, and I choose the modeled, it resizes whatever that circle was to be that thread. So maybe diminishing returns to try to define that circle if it gets defined in this thread function anyway. But it's totally up to you on what your best practices should be. I'll increase this thread size to about 3. We have a 3 so like a 3 by 2 stub Acme, right? That's 2 threads per inch, outer diameter of 3. I'm doing nominal right now. Of course, we can fine-tune the size if we want to have production threads with production tolerances. I'm going to keep it simple with nominal for now. Now in nominal, if I just stand on this outer face, I can see that our outer diameter is indeed 3. If I stand on this inner face, I can see that the radius is 1.35. Now, one way to just have a quick treatment on the outer face of these threads, if I go back and edit, is that I can choose create a chamfer on the edge. And if you can see, this chamfer softens the outer edge. This is very common, and I think in most cases, for most kinds of threads, this is a great solution. But for those who specifically need blunt start, there's not a native way to create that blunt start. So actually, first off, I think I will make sure that I don't have a chamfer, and let's start working on making a blunt start. First things first, I can choose my ZX plane, and we can see that the thread begins right on this plane, right? So I can create a sketch on here, and I'm simply going to go up the first thread, right? So this is one complete revolution right here. Once again, I can see that my radius is 1.35. So I make a rectangle, and we'll give this a dimension of 1.35, that radius. And now I know I'm sitting right on that face. And I'll go just out enough to know that I've captured the entire thread cross section right there. We'll give that 0.15. We'll give that 0.415, or, well, you know, just whatever dimension is good enough to capture that whole thread. We'll give that 0.25, right? So we've created something that captures the whole cross section of that thread in the sketch plane. And now I can do an external thread. Now I know that my threads per inch is 2. So what I can, oh, and I chose thread, I meant to do subtractive helix. I can choose my sketch 2 is the sketch to revolve. My reference line, of course, is this one. And then for the pitch, since I have 2 threads per inch, we're going to invert that to be 1/2. So it's just 1 divided by whatever your threads per inch is. For ANSI, for ISO threads, that's right in the name. So just use the thread pitch from the name of the thread. Very easy. And I'll click reverse. And we were able to just cut off that thread before it goes to the very end, which is kind of what we want. I think that's how most of these threads are. Now, one option that we can do is I can take this sketch, I'll go in my ZX plane and take my sketch 2 and just project it, making kind of a replicated sketch here. There we go. And I can take this new sketch, sketch 3, and I can do another subtractive helix. And once again, same pitch. And I can add something like a 60-degree taper angle. And that's nice and easy for a blend entry or ramped kind of helix. And of course, by changing our taper angle, we can change that ramp. Maybe I want 80 degrees, right? And that dramatically changes things. So we can choose a value that we like and call it good. Maybe we want to have a little bit more precision, or at least do a little bit less math. If that's the case, one other method that we could do is we can go to our plane. We'll select this axis and this plane as references. Maybe I want to have a 35-degree ramp, and I'll reverse that, right? Maybe we really care about, or we really need to be precise with when a ramp ends. And this plane can mark that ending point. So we'll create a sketch here, and this time we want to make the same sketch as before. In fact, I could probably just project this whole thing as a reference, like that. And I'm going to say equal, right? So we're equal here. I'm going to say vertical, so we choose a vertical constraint right there, and a vertical constraint right there. And then we know that this has an outer diameter of 3, so we'll give this a dimension of 1.5. And that should get that resting right at the top of our thread where we want that ramp to end. And so now from here we can do a loft. I'll hide my planes, show my sketches, and I'll choose a subtractive loft to go from here to there. And I think I selected the wrong sketch, so I'll be very precise about it. I'll go for my tree sketch 4 and 3. You can tell that we have a pretty straight loft, and we can choose the tangent so that we can see that it's coming now tangent out of the sketch. Same over here. I can change the tangent magnitude to be something that makes a little bit more sense for what we're doing. That looks about right. We'll go tangent over here as well. So now we have a ramp that comes out nice and tangent and curves smoothly into the thread. That would probably be a G1 curvature right there. And we can up it if we want it to be even more smooth, right? So just like that, that looks pretty good. So there's another lofting method if we need to have more of a curvy ramp that's tangent on both ends. Hopefully that is helpful. Thank you so much for watching. Please subscribe to the Alibre channel, and we'll see you in the next one.